In this video we're going to go through a full design cycle for an inverter. Now I'm working with two screens at the moment, so you will see my head turning to the side every so often to work on my other screen. So let's start off with us in the Explorer tab here. And what we want to do is create a library. So there's already a library there, so you can right click it and you can click on Save Library As. Now whenever you click on that, you're going to have an option to save it somewhere. So as I said, whenever we've ran up this tool at first, we would have an electric in our folder in our desktop, and that folder will have a subfolder called Designs. So this is where we're going to keep all of our designs. And we're going to rename this, so we can call it inverter underscore tutorial. Okay, so we've got the inverter library here. Now if we again click on that and right click, and you can go into create new cell and make sure you're clicked on the schematic, and we'll call this cell inverter. So that's us got our library and we've got our schematic for our inverter. So whenever we create this schematic, it gives us access to all of the components that we need. So if you click on here, you'll see the components down the left hand side. These are the two ones that we're interested in here. We've got our NMOS device and we've got our PMOS device. So if we click on the NMOS device and put it over here, and we click on the PMOS device and we can put it over here. Now you'll notice on my screen I've actually got a grid, so you can turn that off and on by typing in Control and G and the letter G. So Control G turns it off and Control G turns it on. You can also fit this to the screen so it's fitted properly. There's a fill window. So if you click on that fill window, and you'll see it fills the full screen. Now a thing to note here is that what we have here are 3 terminal devices, but we actually want a 4 terminal device. We've got to have the bulk as well. So if you click on your transistor, and you can head over to the file, the edit and change, and if you head up here, you'll see that there's a 4-port transistor. So click on that, and we're on the PMOS one, so we're looking for PMOS 4. So that's PMOS 4 here. So just press change on that and you'll see we've got the little arrow now appearing. Now we do the same for the NMOS device. Click on it, click on edit, change, and we're looking for the 4-port transistors, and we're looking for the NMOS. So there's the NMOS 4 up here. So click on that, change, and done. Now one other thing to note here is that the bulk connection here for this P-type device, the PMOS, is going to be up at the top here. So it's going to be connected to the VDD. So we really want this up the top here. So if you click on this one here, and then you can get into the edit and mirror and press the up down, and you'll see it's changed that to this point up here. Now we can connect the devices together, so in order to do that we left click here and then we right click, and it's created that line, and we can left click, right click, left click, right click, left click, right click, and we can zoom out with a little zoom here, so you click that and then you can use your roller on your mouse to make it smaller. Now we also want to have the power, so the power is here, so it's this one here, so click on it, and we can left click, right click, and the ground is this one, so the ground is down here, so we can left click, right click. We also want our input and output pins, so those are going to come from here, so the input's going to come from here, so left click and right click. And we need the pins, so this is a input and output pin here, so we click on that, and again we left click, right click, and we've got the output pin is the same one. We place that down and we can left click, right click. Now we want to give the pins names, so if we click on this one here and we can export, create export, and we'll call this one in, and we'll go to this one here and we'll go to export, create export, and we'll call this one out. Now the length and width are given by these values here, so the larger one is the width, and we want to change these, and mostly we'll be changing the widths. So in order to get access to this, whenever we click on that, it grabs the transistor, but we actually want to grab the little numbers here. So you can use the control key, control and then left click, and you'll see it actually works its way through the options. So it's grabbed the transistor and now it's grabbed the number here. So we can grab this number and we can move it over, and then we can grab this one here and move it over, and we can grab the 2 at the bottom as well. Okay, so we're going to change these, and we'll make this one a value of 20, and we'll make this one here a value of 10. We can always change these later on to see how it changes the output, but for now we'll stick with these values. Now we also have to get access to the SPICE model. So to do that, we click on the device here, so that's our PMOS device, and we can come in here and go to Tools, and there's a Simulation SPICE, and there's Set SPICE Model. So you click on that, you get this little file up here. So again, Control, and you can grab it, and you can double click on this, and we'll call this CMOS P. So this ties up with the model that we've got for our SPICE simulator, and we've got this one here. So this is going to be the same again, Tools, Verilog, SPICE, Set SPICE Model, and we'll Control and select it, and this one here is going to be called CMOS N. So you must call these CMOS P and CMOS N in order for them to find them properly within the technology file that we're using for our SPICE simulator. Now there's one other thing we have to do here. We have to connect the bulk connection. So in this PMOS device, we connect from here up to the VDD. So left click, right click, left click, right click, and left click, right click. So that's the reason why we mirrored this, so that we could have easy access here. Again, left click, right click, left click, right click, left click, right click. So that's us finished our design. What we really want to do now is go ahead and check and see whether the design is actually working properly, it's actually connected up properly. So you can do that with a design rules check. So go into Tools, DRC, and check hierarchy. Now see here it's come up with 2 errors and 0 warnings. So we want to go and have a look at the errors. So you can see the errors in here. So if you go to the Explorer and you see the errors, click on that, inverter, and whenever you're doing this at first, you see that the errors, these are typical errors that will come up. So if you double click on this one here, you see it's showing an extra pin, so you can click on that and just press delete. And again here you can click on that one and just press delete. So run through that again. Design rule check, check the hierarchy, and you'll see at the bottom here it actually says 0 errors and 0 warnings found. So that's us went through the first process or first stage of building our CMOS inverter. What we want to do now is create a symbol for this so that we can use the symbol throughout the hierarchy of our designs. So let's go ahead and we'll do that now. So if we go and we click on the view, and there's a make icon view, so click that, and you'll see that it's actually created the icon up here. But the icon doesn't look very much like an inverter, so we actually want to go and change this. So in order to change it, if you click on this over here, you see it's actually created another little blue circle here, and it's got inverter IC, so that's inverter icon. So if you click on the icon, so this is just simply the icon for this schematic here, okay? So we double click on that and you can see that we've got the inverter icon. So we'll change this so it looks actually like an inverter. So we just click on the router side here. We'll delete this off. Now we're going, if you look at this one here, you can see the pin for this is over here, and we've got to this one, you'll see the pin for this one is over here. So we'll grab this one here and we can shift it over this point here. But again, we want the pin over the other side, so if we grab the pin, we can just move it to this side here. Now you can see that's the pin being moved. And what we want to do is create the inverter symbol. So we've got access to the symbols now within this icon library. When you go to components, we get access to all these symbols. So we can get in, grab the triangle. We stick the triangle down here. But in order to change the orientation, you can press Control and the letter J. So J changes the orientation. So that's us oriented in a different fashion. Now we also want the little circle as well. So there's a circle here. So we can bring the circle over and stick it in here. And we can double click within the here to get the sizes. And we'll change the sizes to 2 and 2. And we see we've got our circle here now. So let's just move this out and we'll make it just a little bit neater. And we'll move this to this point here, and we've got our input. Okay, so that's a little bit tidier now. And if we now get into our Explorer and head into the inverter, you'll see we've now got an inverter symbol here. But what we want to do is we want to run through a simulation with this symbol. So within this symbol, we're going to have this schematic, but we want to create an actual file here to run the simulation in. So you have to go again to the cell, new cell, and we'll call it, make sure it's under schematic, and we'll call it inverter underscore sim. Press OK here. So now we've got a schematic here, and we're going to run our simulation from the schematic. So in order to to build up the actual hierarchy, we're going to have to go and grab our actual symbol. Okay, so that's our inverter symbol here. So we can grab this and we can drag it over, and we can see we've got our inverter symbol. So we'll go in here, Tools, Window, Fill. I'll zoom out just a little bit. Now what you want to do here again is we want access to these pins, so you can get in, you can left click, right click, left click and right click. So we're going to name the input and output. So if you click on this one here, and again you go to the export, create export, we can call that in, and this one here, export, create export, and we'll call that out. Now in order to run the simulation, we need a file in order to tell it what input parameters we're going to have, for example the voltage levels, and also the type of analysis you want to do, a DC analysis or a transient analysis. So what we can do is, while we're still in this inverter schematic here, you can get into components and you can go to miscellaneous, and there's an option here for spice code. So just click on that and drag this in, and you'll see you've got a little text here. So with that selected, if you do Control I, you'll see you get another window up here. So make sure this multi-line text is clicked, and we want to put the text in here. Now there's already a code generated for this, and I'll show you how we generate this code in a different video, but for here we'll just copy and paste what we need into this position. So what you can do is if you go into your original zip file with all of your code, you'll see here that there's one called inverter_DC. So if you double click on that and just copy what we've got here, Control C and paste it in, Control V. Now one thing to note here is I've got an include file, so I'm including this technology file here, and I've put it in my folder here called electric, and this is this TSMC_018 micrometer model text. So I'll show you where that is. It's sitting in your original zipped file here. Okay, so that's this file here. So you want to take that file here and just stick it in your electric folder as I've done here, and we're going to refer to that file. And again, that file's just got the models in it, so if you double click and have a wee look at it, you see here it's got the CMOS N file here, and it's got a CMOS P file. Okay, so there's nothing, and this is just all the model parameters for your particular device. And you can see here that it's got how many model parameters, so you can see how complex these models are. Okay, so now that you've got those here, you can just apply that. You can press OK, and that's us got this file here, and it just tells us the inputs as well, the type of input. You can see it's a pulsed input, and it's going to have the pulse width associated with these values here, but we'll talk about that in a different video. So now what we can do is we can go ahead and we can simulate that. So you can go to the tools, spice simulation, and you can simulate spice and write spice deck. So if you click on that, and that's it done. So if everything's A-OK, it should come up at the bottom that it's running the spice file here. Okay, and everything should look just exactly as we have here. Now let's have a look and we'll see the input output characteristics for this. So if you click on the little wave icon here, and you can choose the input, so V in is the input and V out is the output, and press OK, and you can see here if I make it a little bit bigger, you can see that as the input voltage changes from a 0 volt, so the gate voltage is 0 volts, so, and as the gate voltage rises up to 1.8 volts, you can see the output goes from 1.8 volts down to the value here of 0 volts. So that means that we're going to have the input going high and the output is going low. Now in this instance here we've got a 1.8 volts here for the supply rail, as opposed to the 5 volts which we had been talking about previously. In this process here, we want to keep the power down as low as possible, so if you can do that by keeping the voltage level at the power rail as small as you possibly can. So that's why we've got it down at 1.8 volts here. But that doesn't matter, that's just details for us at the moment. We just want to know how to run the tool up and simulate it and get it actually working. So that's the DC analysis. So let's have a wee look at the transient analysis, and we'll show you how we're going to work through that. So again, what you can do is you can click on this and you can go Control I, and again we'll go into your original file here, which is your zip file with all of your values in it, and you'll see here there's one called Inverter Transient. Now this is just if you double click on it, you'll see it's just the same as the previous one, but this line here is different because it's going to give us a transient analysis. So again, you can go Control C on this, and we'll go Control V. So the only difference is that it's now a transient analysis. So you can apply that, you can press OK, and we're ready to run the simulation again. So you can go Tools, Spice Simulation, Write Spice Deck, and again it's worked through that for us. And what we'll do is we'll look at the input and output again. So we want to click on the little icon up here, and this is the input, that we're interested in. This is the output. If we OK that, and you can see it's running through this transient analysis, and you can see that as the input goes high, the output, which is in green, goes low, and again the input goes high, the output goes low. So it's just, all it's doing is just changing the gate voltage, and it's making it a low level to, it's going from 0 volts to 1.8 volts to 0 volts to 1.8 volts, and as the input changes, the output changes in the opposite fashion, so it's inverting. So that's working as we expected it to work. There's a lot more detail in this that we could look at, in terms of the transient response and the time it takes for the input-output changes to occur and things. But these are all details that we can get into probably in a different course, because there's too much detail here than we needed for an introductory course. So that's this video going on now for over 20 minutes. I think that's long enough. What we'll do is we'll continue this on the next video, and we'll lay the device out, and then we'll run the simulation in the layout. So thank you for listening. I'll get you on the next video. Goodbye.